How do you guarantee your corporate data remains secure even if a cybercriminal successfully breaches your entire network? In this lesson, you will learn how. Welcome to the final session of the Cybersecurity Masterclass, where we transition from network access controls to ultimate data protection. Throughout this series, we have constructed a highly resilient zero-trust architecture, deploying micro-segmentation, MFA, and rigorous least privilege protocols. We have built an incredibly sophisticated digital fortress, significantly reducing the probability of a successful external breach or internal lateral movement. However, in the modern threat landscape, security leaders must operate under the uncompromising assumption that a breach will eventually occur. A zero-day vulnerability, an advanced nation-state exploit, or a maliciously compromised insider could eventually bypass even the most robust perimeter. When the network defenses fail, the only thing standing between your enterprise and a catastrophic public disaster is advanced data encryption. Encryption is the mathematical process of scrambling readable plaintext data into an unreadable, chaotic format known entirely as ciphertext. Without the specific cryptographic decryption key, the exfiltrated data is mathematically useless to the attacker, completely neutralizing the ransomware threat. To implement this defense effectively, we must architect encryption across two distinct states of corporate data: data at rest and data in transit. Data at rest refers to the massive volumes of static information stored within your local hard drives, servers, and cloud databases. Legacy IT environments often rely on simple storage-level encryption, which automatically decrypts the data the moment the server is powered on. A modern enterprise must demand database-level and application-level encryption, ensuring data remains scrambled even if the physical storage is fully compromised. Data in transit refers to the constant flow of information moving across the network between your microservices, APIs, and remote employees. Every single byte of data transmitted across your corporate infrastructure must be secured using Advanced Transport Layer Security, or TELS protocols. If a cybercriminal successfully intercepts the network traffic via a man-in-the-middle attack, they will only capture useless, mathematically scrambled digital noise. However, simply encrypting the data is entirely insufficient if your enterprise fails to secure the actual cryptographic keys used to unlock it. Storing your encryption keys on the exact same server as your encrypted databases is a fundamental, catastrophic architectural security failure. You must implement a dedicated, highly secure key management system, often utilizing physical hardware security modules isolated from your primary network. Furthermore, these cryptographic keys must be rigorously rotated and updated continuously to limit the potential blast radius of a compromised credential. But encryption alone cannot prevent a legitimate, fully authenticated employee from maliciously downloading and sharing highly sensitive corporate intellectual property. This introduces the absolute necessity of deploying robust data loss prevention, or DLP, frameworks across your entire digital ecosystem. Data loss prevention software continuously monitors and mathematically analyzes the exact content of the data leaving your corporate network in real time. It utilizes advanced pattern recognition and generative AI models to identify sensitive information, such as credit card numbers or proprietary source code. If an employee attempts to email a highly classified financial spreadsheet to an external personal address, the DLP system instantly intercepts it. The architecture automatically blocks the transmission, encrypts the flagged document, and immediately generates a high-priority alert for your Security Operations Center. Effective DLP requires your enterprise to undergo a rigorous, comprehensive data classification initiative before deploying the automated monitoring software. You cannot mathematically protect your corporate data if you do not objectively know exactly what data you possess or where it resides. Every document, database, and API output must be strictly classified based on its sensitivity level, from public marketing assets to restricted trade secrets. This classification framework dictates the exact encryption standards, DLP monitoring rules, and continuous access policies applied to every specific file. In the era of artificial intelligence, securing this proprietary data is no longer merely a defensive posture. It is an existential business mandate. Your foundational large language models and retrieval augmented generation pipelines rely entirely on the integrity of this classified corporate information. If an attacker poisons your unencrypted training data or alters a vector database, your autonomous AI agents will inevitably execute catastrophic operational failures. You must enforce strict cryptographic hashing protocols to continuously verify that your internal training datasets have not been maliciously altered. Furthermore, as your enterprise expands globally, your encryption and DLP strategies must inherently comply with complex international data sovereignty regulations. The European GDPR and California ECCA mandate strict financial penalties for organizations that fail to encrypt personally identifiable customer information adequately. By architecting a comprehensive data protection strategy, you transform compliance from a burdensome legal requirement into a massive strategic market advantage. Clients and enterprise partners will implicitly trust your organization, knowing their sensitive intellectual property is safeguarded by mathematical certainty. You shift the corporate narrative from the fear of a devastating ransomware breach to the undeniable confidence of a secure, resilient infrastructure. Your digital transformation initiatives can proceed at maximum speed, unhindered by the constant, paralyzing threat of a catastrophic data exfiltration event. Implementing these advanced encryption and DLP frameworks requires a highly coordinated effort between your security, legal, and operational IT departments. It demands a cultural shift where every employee understands their personal responsibility in classifying and protecting sensitive corporate digital assets. The illusion of the secure perimeter is dead. The modern enterprise is secured at the granular level of the data itself. To assist your security engineering teams in operationalizing these protocols, I have published a comprehensive data protection and encryption guide. This documentation details the specific AES 256 cryptographic standards, tells configurations, and key management system architectures we have discussed in this module. It provides standardized blueprints for executing an enterprise-wide data classification initiative and configuring automated data loss prevention network rules. You can access this critical operational documentation immediately in the professional GitHub repository linked directly in the video description below. I strongly encourage you to review these cryptographic frameworks with your Chief Information Security Officer to secure your digital infrastructure today. Let us quickly recap the rigorous architectural journey we have successfully completed throughout this comprehensive enterprise cybersecurity masterclass series. We began by completely destroying the obsolete illusion of the legacy corporate firewall and the catastrophic dangers of implicit network trust. We architected a robust zero-trust foundation, centralizing identity management, mandating multi-factor authentication, and deploying highly secure cloud micro-segmentation. We mathematically minimized the corporate attack surface by eliminating standing privileges and enforcing the strict doctrine of continuous least privilege access. Finally, we secured the underlying digital assets through advanced, multi-layered data encryption protocols, and automated real-time data loss prevention systems. You now possess the uncompromising architectural blueprint required to defend your global enterprise against the most sophisticated, modern cybercriminal syndicates. The era of perimeter-based ID security is officially over. The organizations that adapt to continuous cryptographic verification will dominate the market. Your absolute responsibility as technical leaders is to implement these rigorous defensive frameworks with an unwavering commitment to operational security. Without this modernized digital fortress, your enterprise cannot safely deploy artificial intelligence or scale its highly agile cloud computing infrastructure. Share this entire masterclass series with your executive board and engineering teams to precisely align your corporate cyber defense strategy today. You possess the academic foundation and practical architecture required to lead your industry securely into the next generation of global computing. Subscribe to the channel, a final GitHub repository linked below, and take your rightful place at the forefront of the vanguard.